Welcome to today's GATE video. I am Sathiyavathy, working as Assistant Professor in the Department of CSE Cyber Security in SA Engineering College. Today I am going to discuss about the topic in computer networks, two topics which is of distance vector routing and then link state routing. Let's start the session. First one is distance vector routing. Okay, what is distance vector routing? In distance vector routing, main concept is each and every nodes get the routing table. Okay, in routing table, it will update what is the distance present. The distance is the cost. The distance is the cost, and this A, B, C, A, B, D, E, F, G, which is all the nodes. How each and every node get connected to the destination node through the next hop. Each and every node having the routing table. In routing table, it will containing the next hop cost. What is the distance? That is the distance count as a cost. Okay. The main thing in distance vector routing is exchange the lowest cost path. Why we are going for this both routing is the main concept of the both routing system is to find the shortest path to reach the destination from source to destination node. How the shortest path to be calculated, and then how fast the communication of each and every packet in a network to reach the destination from source to destination. Okay. So here in this, each and every node toward itself is considered as a cost as 0. To other node, whatever the cost, it should be as entered in this table like this. The main thing is in distance vector routing is iteration, because it will each and every next hop will contain the routing information of the other connected node information. For example, A, which containing the data about the B node information in the routing table about the cost, how much distance is get connected. It is a local sharing of information, right? The node containing in every node containing the routing table have the local knowledge only. So the looping is occur in this particular distance vector routing. How the looping will occur means because each and every time while exchanging the information, instead of locking the steps, the iteration is going on till it reach the destination. Because if there is any sudden change in the particular network between the time intervals, if there is any change in the network cost or network node, then what will happen means it should be get updated in the routing table routers. By using the routers, the routing table will get updated. So because of this, each and every time it pass through all the every node to identify the least cost in the particular network through the next hop. So here in this, wait for change in local link cost or message from neighbor. So if there is any change, the particular node is wait for the local link cost change, and then recompute the distance table. If there is any changes in the particular node connection between the link cost, then again it will rechange the routing table according to the cost to find the shortest path. So each and every time the neighbor notify their neighbor, if necessary, if there is any changes occur, then only the router present which containing the routing table will get update of each and every cost from one hop to another hop distance. Okay, first step in this is all the routers should be present in the network, the distance to its neighbor router only. The second step is each router should exchange its distance vector to its neighbor router. Whatever the distance it travels, it should be get updated in the particular routing table of each and every node router. Each router prepares a new routing table. Each and every time while finding the transition, the routing table is get prepared by the each and every node till it reach the destination. Similarly, so what will happen? Similarly, it repeat for all the every time while finding the destination. According to the destination, it's travel from each and every path. So n number of times it need to identify the path due to updating the table, routing table. So n minus 2 times the routers of n routers in the network. If there is a n routers in the network, n minus 2 times it will keep on update. So after this, the routing table, you need to find the converge or stable, which is the stable path for the find the shortest path. So this is the main distance vector routing. I have just used the example. There is a network consists of 4 routers, A, B, C, D. The weights are mentioned on the edges. Okay, A to B 2, and then B to C 3, and then C to D 11. And then A to D 1, and then B to D 7, B to C 7. Likewise, you are having B to A also. These are all the dynamic routing algorithm. Distance vector routing is otherwise is also called as dynamic routing. So similarly, you are having D from D to A, D to B, and then D to C. These are all the weightages of our cost of each edges while traveling from one node to another node. Next is that is also called as a cost, which is also as distance. Here the table for a router, because each and every router here should maintain the routing table. This is the routing table which is contained the destination and then the distance and then next hop. Distance is nothing but the cost of traveling from A to B 2. Okay, here first destination is start from A. Okay, what is the next hop to A? From A to A, there is no path, so it is as a 0. This is the main thing in distance vector. Whatever routing table present in the particular router distance is considered as a 0. For example, here the router table for B, the routing table here consisting of B, which is having a no distance within it, so it is as 0 to B. Next hop is B. Similarly, here come to here A 0, there is no distance from here to here, so next hop is A. To next hop, if it is A means 0. Next hop is B. Okay, A to B, the next hop is 2. So next hop count is 2. From A to B. Okay, next is C. If you are passing through the C, why the distance cost is infinity? Because you need to pass through the from A, you need to pass through A to D and then D to C. So you need to intermediate, there is a one node you need to pass through. So what is the main concept in this distance vector routing? It will get update in the routing table the next hop only. What is the next node it contains? So according to this, the next node to A is B, the next node to A is D. The C is in C and A, there is no direct connection or direct link from A to C. It need to pass through D and then it need to reach the C. So that's why it is as distance cost as infinity. So there is no next hop. Next one is D. From D, what is the cost? From A to D, there is a path which is a link which consisting of path 1. So it is 1. So D is the next hop. Similarly, you need to create all the table for each and every node. Here B, another example, A to A. So from here, you are having the next hop of A, which is from B. So which is from B to A, 2. And then from B to B, there is no node, so 0. Similarly from C, starting from B to C, which is of 3. B to D, which is of 7. So next hop is 7. Similarly for D, next I am taking D. From D, what are the things? From D, you are having A and then D which passes through directly to B as 7 and D as 11. For D itself, there is no next hop, so it is as 0. So D to next hop, there is no 0. C which is of 11. So D to C which is of 11 and then B to D which is of 7 and then D to A which is of 1. Okay. Similarly for router C, you are having two connection path link which is from C to B as 3. So C to B which is of 3, and then you are having C to D which is of 11. So next hop you are having here. So similarly for C to C, there is no C to C path cast, so it is 0, and then you are having next hop connectivity you are identifying, that's you need to put here, that is C. Similarly here A to C there is no direct connectivity path, so it is as a infinity. Okay, so here what is the next thing we need to do is, similarly for C also you are identifying, then this is the next main concept to finding the shortest path, that is the minimum value. How you are finding the minimum value? For finding the minimum value from B and then from D, the things I am taking from B and then from D. From previous routing table we have calculated what are the cost obtained for the from A to B, what is the cost. By using that reference table as mentioned here in the previous slide 2037, you are taking it here for the reference. From D also 17110, this is the cost, you are taking it as taking it for reference, that is D table, you are having the D value as 0, and then B table you are having the B value as 0, because there is no next hop the similar B or D. Okay, from this the minimum value how you are going to find for the path. Cost of reaching the destination B from router A. From router A, how you are going to find the destination to B, that is you are having 2. First one, that's why you are mentioning as 2. Next from B to A, what is the next thing? You are having no connectivity, so 0. Next from 1 plus 7, you are having the path connectivity 1 here. Cost of reaching destination C from router A. From router A, what is the cost to reach the destination C? First one is 2 plus 3, this is the minimum cost. Another one is 1 plus 11 to reach the C. Okay, so by comparing these two value, which one is very least amount, that one you are taking it as a cost for the shortest value. For example 2 plus 0, 2 is the smallest value cost, so you are having it as 2. Which way you are moving? B. Similarly here 2 plus 3, 1 plus 11, which one is the shortest path is 2 plus 3 which is 5, so you are picking it the path and moving to that particular shortest path. Similarly for reaching the D from router A, you are having to D reach 7 plus 2 and then 1 plus 0. So 7 plus 2 which is 2 plus 7, 1 plus 0, 1. So you are reaching it via D. Okay, likewise you are similarly going for router B also. Each and every reference table I taken it as which is the least cost you are mentioning here itself, you can identify, and then minimum cost. Why you are going for here 3? Previous one you are using the only 2 distance, because you are having the 2 connectivity path from A, 2 connectivity path. So the 2 comparison is need to taken, which path is suitable. Here for B you are having a 3 connectivity path, B to D and then B to C and then B to A. So this is the connectivity path. From routing table you are having the cost alone for the reference here. So this is the routing table. So minimum cost from destination, cost of reaching destination A from router B. From router B, what is the cost to reach the destination A? So first one is 2. From that you reach the A, so 0. Next one is 3. From 3 you are having then the infinity value, and then 7 plus 1, this is the another path you are having. So you are identifying the least. Likewise you keep on repeating the for router C and then router D by comparing each and everything. This is the question. This is the gate question. Consider a network with 5 nodes N1 to N5 as shown in the below. The network uses the distance vector routing protocol. Once the routes have been stabilized, the distance vectors at different nodes are as follows. What is the thing? These are all the routing table containing information. For example, N1 which containing as 0, because N1 to N1 is 0. There is no next hop. Next one is N1 to N2 1, and then N1 to N3 which is 6 plus 1 is 7. Correct. Next one is N1 to N4, 6 plus 7, 8, and then you are having 6 plus 1, 7. Next one is N1 to N5, 3 plus 1, 4, which is of shortest path. You need to take the shortest path. This is all the questions given. What is the task given for us? They are given N1, N2, N3, N4, N5, each and every routers, the routing table, which containing the next hop as a cost. In what is the question they ask means, each distance vector is distance best known path N1 to N5 where the distance to itself is 0. We already know that, we previously discussed. Also, all links are symmetric and the cost is identical in both directions. The cost is identical. From N2 to N5 is 3, N5 to N2 is also 3. Okay. In each round, all nodes exchange the distance vector with their respective neighbors. Each node, it will exchange the information. For example, N3 to 6, 6 plus 1, 7. Likewise, it will exchange the information. Then all nodes update their distance vectors. In between two rounds, any change in cost of a link, it will cause the two instant nodes to change only that entry in their distance vector. That means if there is any cost in between get changed, what will happen? Then what are the values passes through the particular node, the particular table is also get updated. So what will happen? The particular path traveling through whatever cost through the traveling, it should be get updated. It may be a 2 or 3 tables based upon the cost what you are changing. For example, N2, the cost link N2, N3 reduced to 2. What does that mean? N2 to N3 which is 6. Changing it to 2 in both direction. After that, what will be the distance vector at node 3 they are asking. Okay, node 3, what is this node 3? Okay, what will be the value? Node 3 means, if we already know, what is the value node 3 you are having the next co-op? It should be as 0. So node 3, 0. You are having, but all these things A, B, C, D you are having 0. It's not possible to identify which choice. Okay, next thing, what is the next thing means? From N3 to N2 and then N1. What are the things? First one is A. That means A node, what is the cost you are having? Okay, 6 plus 1, 7. Okay, next one is from N3 to N4, 2. Okay, next one is N3 to N5. What is the cost? 6. And then N5 you are reaching. You can pass through like this or pass through like this. 4, 5, 6. Okay, next one is, so 6 you are having here. And the next one, what is the next thing? To reach N1 you need to reach 6 plus 1, 7. Okay. So here there is the answer is A, which is you are having 3, 2, 0, 2, 5. That means you are having the particular node as 0 and then 3, which is from N3 to A node. 3 and then 2 and then 0, 2, 5. So as soon as N2 to N3 is reduced to 2, both N2 and N3 which is instantly changes. So whatever nodes you are going, the value, particular value is changes. For example, 10273 and then 7202326 becomes this. Likewise, it keep on changing the table whenever the particular distance cost is get changed. Similarly, this is another example you are having PQR. Okay, another example question. This is a distance vector routing question. In that R fails, what is the particular random time period it will take to each at the same average rate? The probability of routing loop information. If it is rounded off in a decimal point, they are asking if R fails, how the communication for P and Q after this particular router information get failed, because the connectivity is from P to Q and then Q to R. So what will be the routing table? They are asking about the converged. What is the converged probability of that? Okay, the correct answer is 0.5. How means if P and Q is both linked together, if R is failed, it will keep on communicate with the Q, and then Q will again send the P. It wait for a delay. Some delay it will take in order to recognize that R get failed. So how much delay it will? Average delay it will identify. So it is a given path, P and Q sending update to the average date. So one P sends before Q and the other is Q sends before P. So if you have two conditions, Q sends update to P first, then P first find the value of R such that it will be infinity because R is failed. So count to infinity will not occur. So P sends update to Q first. Again P will send the update to Q. Q found that P has a way to reach R. Again the Q will identify if there is any path to reach R. So R is failed, so there is no infinity. As Q and R is broken, R cannot send any update to anyone. So totally you are having the two connection, one failed. So 1/2 which is of 0.5 for count to infinity. Next is link state routing. Okay, what is the main distance vector routing? What you are doing means each and every distance, if there is any update, each and every table is need to update. Each and every routing table is need to update in order to identify the distance. But in link state vector routing, this is the connectivity. The whole flooding is occur because each and every network connectivity need to identify what is the message is keep on processing. Instead of local knowledge, it will identify as a global knowledge. Initially each and every node itself need to identify the local connectivity, and it passes through in between 2 or 3 nodes also if there is if the topologies get changes. So there is no need to each and every time to update the routers. Okay, the main disadvantage here is the flooding of message, because in a network it keep on, if the topology get changes also the traffic will occur, and then it need to identify the least cost among the which one is to reach the destination. Okay, A connected to B which is of cost B, and then A connected to D which is of cost 1, A connected to C which is of cost 5. This is path is also possible, it is also 5, but direct connection from A to C is 5. That's why they are indicating 5. Similarly, for link state routing, there is using a Dijkstra's algorithm. In distance vector routing, you are using Bellman-Ford algorithm, but in link state routing, you are using the Dijkstra's algorithm. Dijkstra algorithm, which is of link state flooding, it accommodates the link state flooding. All nodes have same information. In order to find the least cost from one node to all other nodes. Okay, the main task is the net topology, link cost to all other nodes. In distance vector, you are identifying the next hop. Next to hop, what is the routing table containing the router information. But here, the one node need to know all the information in the network. What are the routers get connected? What are the information? What is the cost of the other nodes also? The previously itself, in initial stage itself, all networks know what are the connectivity and the links and what are the cost. That is the thing. Cij, which is the link cost from node I to j. Cost infinity if not direct neighbor. If there is no any direct neighbors, then particular thing is considered as infinity. For example, you are having A to B, if there is a cost 2 means it's okay. For if you are having A, B and then C, in order to find the C, you are having no any connectivity from A to A passing through B and then C is also possible. But A, B, C and then D, you need to connect the from A to D. If there is intermediate 2 nodes in between, then the cost is identified as infinity. That is the main thing. Next one is DV, the current value of cost of path from source to node B. Next you are going to identify what is the A and then next node is B. So that is the node V here indicated. And then the predecessor node. From in order to reach C, you are going to pass from A and then B and then C. So that is the PV. The set of nodes whose least cost path is you are going to identify it as Dijkstra's algorithm. The first thing here, start from in this diagram, starting is from A. And then DB and PB, this is the path. Okay, from A you are reaching B, which is the cost as 2. From A you are reaching, that you need to mention. Next one is from A to A to C, you are having the path as 5. So that is the 5, and then from A you are having. Next about D. D, what is the thing? You are having direct link as 1. So 1 comma from where? A you are having. Here you can clearly understand. What you are having here? E. So E in between, what is the node? D. And then if you are going to pass through here, you are having the intermediate node as D. From here you are having this B, C, 2 nodes. So that is the infinity. So in the distance vector routing, what you are doing? You are updating the routing table information and then pass through to the next hop containing the information of the routing information of the present in the routing table. Here you are going to, you can pass through anything, but there should not be 2 or 1 in between if it is the cost is as infinitive. For example, F, again A, B, D need to pass through F. The cost is also high, and then you are having to need to pass through the 2 intermediate nodes. So it is a infinity. Next. Next, you are having a to D as a 1, which is of cost, starting from A to D 1, and then C. In order to reach the C, you are having the 4 and D. So through D you are having 3 plus 1. Okay. Next one, 2 D. For E you are having passing through 2 and D. For E, passing through D, you are having 1 plus 1, no problem, no issues. If you are going to pass through more than 1 node, then it is the thing, it is called as infinity. For example, F, from D to F, what is the thing? You can pass through here, but you have too many nodes, intermediate nodes from A to reach the F. Okay. Next one, ADE. This is the next thing. But already passed through AD. Next one is A3, ADE. Main advantage compared to distance is whatever thing you already visited, you need not to repeat it again and again in order to form a loop like structure. So here 3 for E. In order to reach C, path C through E. 1 plus 1 plus 1. Here also you are having a path, but this is the shortest path value, you are having a 3. And then to reach F, which is of E, through E, you are having a 4. That is 2 plus 1, which is of 4. So you visited A, D, E. Next is B node. Okay, for B node, what is the value? And then C node. Okay, you need to reach up to F like this. Okay, this is the question. Consider the following 3 statements about link state and distance vector routing protocols for a large network with 500 network nodes and 4,000 links. Okay, large networks. In a link state routing, you are having a 500 networks node and 4,000 links. The computational overhead in link state protocols is higher than in distance vector protocol. First option, distance vector protocol with a split horizon avoids persistent routing loops but not a link state protocol. This is the second statement, and the third statement is after a topology change, a link state protocol will converge faster than a distance vector protocol. Which one of the following statement is correct about S1, S2 and S3? Which is the correct? S1, S2, S3 are true. S1, S2, S3 are all false. S1 or S2, but S3 not, it is a false. Or S1, S3 are true, but S2 is false. Okay, what is the first? Computational overhead in link state protocol is higher than in distance vector protocol. This is the 2 thing, because link state protocol you are having a higher value. This is the first one. Statement is true because computational overhead is more in link state protocol because you need to find highest path. Next one is second statement is false because persistent looping can be avoided with the help of split horizon. If you are using a split horizon, the persistent get avoided. And then the third one is after the topologies get changes, the link state protocol will converge faster than a distance vector protocol. Link state vector protocol is more efficient in the dynamic changing or any after changing a topology also, it will obtain the least time to taken to update the tables. So it is true. So fourth option is correct. Next one is consider the direct graph given here. The multiple shortest path between the S. From S it going to reach so many paths here, but which one will be reported by digital algorithm as a shortest path algorithm? Here which one is considered as a shortest path? They given the option as SDT, SBDT and SACDT, SACET. Which one is the best shortest path? So you need to identify from this diagram. So from S, what is the shortest path you are having? From S, you are having A as 4, and then S, you are having B as 3, and then S to reach C, you need to pass through the 2AC node. So it is as infinity, and then from S to D, you have passing through which is of 7. After that all those things E, F, G and T, you are having the infinitive because T is here. You need to pass through so many nodes to reach the T. So it is considered as infinitive. And then from starting from A you are having 4 which is of value from S. And then to B there is no gateway for B, and then for C, in order to reach the C, you have to identify the paths. So it is infinitive. Similarly, you keep on repeating the identification of which node is the best node in order to identify. So here the S to A, and then C to E, A to C, and then C to E, and then E to G, which is having the shortest path. And then another node which is of S to A, C to E, and then T, which is the shortest path. Comparing to these values, 8 is the shortest path, and then the 10 is the longest path. Okay, so option D, which is having the longest path. Thank you so much. Continue again in the other video.